Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks.
Right, part 6, inspection and testing. This has been completely reshaped and restructured in the 18th edition, but you'll notice when you actually land on part 6, chapters 61, 62 and 63 aren't used anymore. We have a chapter 64 on initial verification and a chapter 65 on periodic inspection and testing. I'm also going to look at and peek at Appendix 6 in the rear of the book because of the certificates that are there. Alright then, so initial verification. Let's remember how the regulations works. So the regulation has part 1, scope of protected fundamental principles, what the book covers and what it's trying to do and intentions and what it needs to achieve. Definitions was just reference. And then we had parts 3, 4, 5 and 6. The assessment of general characteristics, the requirement to select protection for safety, the requirements to select erection of equipment, and once all that's done, we have to commission it. We did say in part 1 that the initial verification must be carried out during erection and on completion of the electrical installation. So it's always important in the initial design stage to determine points or intervals where the initial verification is carried out. Maybe before plasterboard is plastered over on all the cable chases, or maybe before the floorboards are laid back down, so you can inspect these areas. So 641.1, every installation shall during erection and on completion before being put into service be inspected and tested to verify, so far as is reasonably practicable, the requirements of the regulations have been met. Result of the assessment of fundamental principles from section 131, the general characteristics in sections 311 to 313, together with information required by 514.9.1 should be made available to the person or persons carrying out the inspection and testing. So the fundamental principles of section 131 was the needs to achieve protection for safety, was the needs to achieve protection against electric shock, thermal effects, overcurrent, fault current, voltage disturbances. It's basically the content of the book. And if you think about that from an initial verification perspective, yes, you need to know what the designer's intended way of achieving protection against electric shock was. If he said, oh, the entire system is ADS, you then need to know that, so that when you do an initial verification, you're identifying that that method of protection has been achieved. If he was to say, oh, this part of the installation is going to be class 2 double installation only, or, oh no, I'll use electrical separation for this part of the installation, but then you identify it's been installed in a way that contradicts that method, that's what the point of this is. You must know about that stuff at the beginning point of an initial verification. Similarly with 514.9.1, that's the diagram that gives you the numbers of points of utilization, the method of protections, and all that stuff. Verification shall include comparison of the results with the relevant criteria to confirm the requirements of regulations have been met. Precautions will be taken to avoid danger to persons and livestock and to avoid damage to property and installed equipment during inspection and testing. So from a person's and a livestock perspective, there's a risk of electric shock. If we're going to be driving voltages through exposed conductive parts and metalwork, such as insulation resistance testing, we need to identify that persons can receive a little shock from that. Livestock, especially with like electrode testing, could even be killed. So you've got to make sure you consider those risks. With regards to the building, we need to try to avoid dismantling or minimize dismantling. So it might be the case that the initial verification is carried out during part of the erection to then later not need to dismantle it further to re-inspect. Take, for example, you're going to do a kitchen, you're going to put in half a dozen spotlights. You want to inspect those connections from an initial verification perspective, and maybe before you even put the lamps in, carry out an insulation resistance test between live conductors before you actually put the lamps in and then push those lamps up and snap them up. Because later on, you're not going to be able to remove the lamps, and if you try to pull the lamps down, you'll probably damage the ceiling. So you should do it at the right time. We should not say on a new installation, limb. Installation resistance test between line and neutral, limb, because the lamps are in. That's not acceptable, because we should put the test into place before the lamps are introduced. So, with an initial verification, we're only supposed to put in yes, ticks, whatever you want to call that, and not applicables. We should not be putting in crosses or not verifieds or limbs, because that's suggesting we've done it in the wrong way. We've done it in the wrong flow. Okay, the verification shall be made by one of the more skilled persons competent in such work. And on completion of the verification, according to Regulation 641.1 to 641.6, a certificate shall be prepared. And so there's a whole list of things to inspect. 642. Okay, and again, this isn't a testing course, so I'm not going to go through all of that. I have covered this list in detail in my 2391 video, but I'm probably going to go over these again in many other videos later on. You have then 643, that was 642, the inspection, must precede testing. That is important to know. And it says that in 642.1. Inspection must precede testing. Okay. 643, though, testing. The test of Regulation 643.2 to 11, where relevant, shall be carried out and the results compared with the relevant criteria. The relevant criteria being the design criteria. The tests are given in the book in the order they should be carried out on initial verification. So the very, very first test you should carry out is the continuity of protective conductor test. Okay? They've now put the protective conductor and ring final circuit conductor under the same test, but it's still the first test. So the first test is continuity of the protective conductors and continuity of the ring final conductors if it's a ring final circuit. Followed by insulation resistance. Okay, it says insulation resistance shall be measured between live conductors and between live conductors and a protective conductor, connecting it to the earthing arrangement. Where appropriate, during this measurement, line and neutral conductors may be connected together. The insulation resistance measured with the test voltages indicated in Table 64 shall be considered satisfactory if the main switchboard and each distribution circuit tested separately, with all its final circuits connected but with the current use equipment disconnected, has an insulation resistance not less than the appropriate value given in Table 64. So this is saying testing a board at once, not the whole building, because it could be a number of boards, but you go to a board and you test all of its final circuits, and you have these values. And they haven't changed, really. So up to 500 volts, 500 volts DC, and 1 meg. Alright. I have seen questions lately regarding what voltage you should use for FELV, because it says in the table there SELV and PELV is 250 volts DC. But it then says underneath, FELV circuits shall be tested at the same voltage as to the primary side of the source, and will meet all the test requirements for low voltage circuits, which means FELV is tested at 500 volts. Okay, so do remember that. That's coming up a lot lately in the exams. There's then a mention of SPDs, and if there's an SPD that we cannot remove for some reason, we should obviously drop the voltage down to 250. Otherwise, the over voltage from the 500 volts DC will just operate the SPD as per usual. We then have mentions of SELV and PELV. We then have insulation resistance of floors and walls, RCDs and polarity. Here's polarity. So verifying every fuse and single pole is in the line only. The center contact of the Edison screw lamp holder is line and the thread is neutral, and just wiring has been correctly connected throughout. The next test is the earth electrode resistance. Then it's the earth fault loop impedance and the prospective fault current. Now, again, these are given in sequence that they should be carried out. That could be another question where it'll give you a number of tests and it'll say 1, 2, 3, 4. Which test? What is the sequence? So, as they're given in the book, it's a sequence they should be carried out in. Functional testing Just to kind of add to this at the moment, there's a bit there that says where an AFDD is installed, the effectiveness of any manually operated test facility shall be verified in accordance with the manufacturer's recommendations. We don't have much information about testing AFDDs at the moment. There is discussion about a testing instrument that can test an AFDD, but it's completely out of reach with regards to its cost and stuff. Right now, it's like an RCD in that we just have a functional button which would open the device like an RCD, and that's all we're given. There is some debate over how that guarantees its effectiveness in a real circumstance, because really we haven't got this information from the manufacturers, but they do have a manual test facility on them, so we need to add that functional check on the actual test. It then says certification for the initial verification. So we need to achieve a electrical installation certificate, which will include a schedule of test results and a schedule of inspections. And the person's signing that, says there, 644.4. The person or persons responsible for the design, construction, and verification of the installation. So design, construction, inspection, and testing. Okay. They are the persons who signed the certificate, not the client, not the person ordering the work or anything like that. With periodic inspection and testing, we've got a bit of information about why we do it. So it will be carried out without dismantling or with only partial dismantling as required, and will ensure the safety of persons and livestock from the effects of electric shock and burns. Protection against damage to property by fire and heat. Confirmation of correct rating of the setting of protected devices. Confirmation of correct rating and setting of monitoring devices, if applicable. Confirmation that the installation is not damaged or deteriorated to impair safety, and identification of the installation defects and non-compliances with the requirements of the relevant parts of BS 7671 that may give rise to danger. Frequency. The frequency of the installation shall be determined having regard to the type of installation equipment, its use and operation, the frequency and quality of maintenance, and the external influence to which it may be subjected. The results and recommendations of previous certificates and condition reports shall also be taken into account. That's quite an easy thing to do, but what we end up doing is going to Guidance Notes 3, and we just say 3 years, 5 years, or 10 years, and we rely on another book, which I think is just crap. But that's what people do because it's easier than thinking. It's clear, it says there what you need to do. The reporting, upon completion, will then provide an electrical installation and condition report based on the model given in Appendix 6. And let's go to that now in Appendix 6. I don't think I have a copy of it here. No, I don't. If I go to Appendix 6, we've got the model certificates. There's a lot of information actually in Appendix 6 now on the certificates. It's built up over time. You've got the from page 461 I'm looking now. So we've got the information for the client that needs to go onto it. Then you've got the electrical installation certificate. And remember, this is a model form. Your form can be, it can look however you want it to look, and it can have whatever information you feel is needed, but this information should be on there as a minimum amount. So with my own personal ones that I use now and then, I'll actually put in thermal imaging, and I'll also put in some arc flash assessments and some other calculations, depending on the client's need, depending what's best for the client to interpret the report. I'll also take some stuff out if it's just not relevant to their report. But this is the stuff that should be in there as a standard. We have the minor work cert. And then we have a lot of information on the things to look for with inspection schedules. It's almost... I noticed this, I think it was when Amendment 3 came out. It was just like a handhold. It's a hand-holding exercise now, this inspection testing. It's a bit of a joke. Then you have the electrical installation condition report on page 473. And then at the bottom of page 474, the codes C1, C2, C3, Fi, and what they mean. And I think I need to do a whole separate video on that because it seems to be the most commonly debated and misunderstood thing in how simple it is to code. It's very, very simple, but people still don't understand and they still question it and they still come up with their own opinions on it. I mean, I've got a Napier Codebreaker book here. It's not too bad. It's got it gives you a lot of information as to how you should think about this. But there are still some scenarios where some things would be a C3, some things would be a C2, some things would be a C1. That the same thing but in different circumstances. So it really is something that I think I need to talk about a little bit more because a lot of people kind of seek for help on it. And let's get to the schedule of test results before we leave. So page 483. All they've really done to this in this new book is added the AFDD functional check column 24. They've added a bit of information at the top. And the reference method line, nothing else that's really that interesting on there. The installation tested voltage is there, so the voltage that you tested the installation resistance at is now needed on that. That's about it really. And then you have the disconnection time in milliseconds and the RC test button operation there as well. So that's a bit clearer as to what you need to put in there. But again, this isn't an inspection and testing course. We're talking here about the regulations content on this. Things for you to be more aware of with regards to your regulations and your exam. Remember the sequence of the tests. Remember the voltages for installation resistance. And remember the coding for your periodics. Those are the most common things you need to remember, really. Okay, we're going to close this video on part 6, and so the next video is going to be part 7. I haven't decided whether to break it down to a video per section, which would be potentially another 22 videos or so. No, I don't want to do that. Or to do just one long video that kind of highlights how the whole thing of part 7 works. I'm leaning more towards that. I think I'm leaning more towards that. So let me work on that, and I'll get on with that soon. Alright, I'll see you guys later.